Why is Earth a paradise of oceans, clouds, and life? What makes Venus and Mars so similar? They're barren, dry. Could another world, maybe even one close by, be hiding a secret ocean like ours? Earth is often called the blue planet, and for good reason. Over 70% of its surface is covered by oceans, lakes, and rivers. These vast, interconnected bodies of water help regulate the climate, fuel storms, and sustain life as we know it. But recently, scientists made an astonishing discovery. Massive hidden oceans trapped in rocks deep within the Earth's mantle. How did we come to live on such a water-rich world? Could it be that Earth is one of a kind? Is it possible that other oases exist somewhere out there in space? Using advanced tools like NASA's Kepler telescope and state-of-the-art ground observatories, astronomers are identifying thousands of planets beyond our solar system. These alien worlds are astonishingly diverse. Gas giants larger than Jupiter, scorched, rocky planets near exploding stars, and icy bodies wandering through space. Among them, a few show signs of water, an essential ingredient for life as we know it. To answer this, we need to look back, far back into Earth's own history, and understand how water came to dominate our planet. Even in the cold vacuum of space, the universe is filled with basic building blocks. Molecules like ammonia, methane, carbon monoxide, and yes, water, form inside enormous interstellar clouds known as nebulae. Oxygen, one of the universe's most common elements, is created inside giant stars and then blasted out during their explosive deaths. Roughly 5 billion years ago, one of those stars gave birth to our sun. Around it, gas and dust began to swirl, forming planets, moons, comets, and asteroids. Today, we find traces of water across the solar system. From frozen moons to distant dwarf planets, Pluto and its moon Charon, for example, are coated in methane and water ice. Neptune gets its blue color from icy methane clouds. Uranus, too, is colored by methane in its upper atmosphere. Inside, they might contain oceans of high-pressure, acidic water that churn like giant batteries, creating magnetic fields. Within Saturn's rings, we find ice particles by the billions. Nearby, the moon Enceladus shoots jets of water from its frozen surface, likely from an ocean hidden beneath. Jupiter hosts storms, powered in part by water vapor. Beneath its thick clouds, and beyond its volcanic moon Io, lies Europa, one of Jupiter's icy moons, a frozen world hiding a subsurface ocean. Europa's surface is cracked and frozen, but beneath it may lie an enormous ocean, warmed not by sunlight, but by tidal friction from Jupiter's powerful pull. Even on Mercury and our own moon, ice exists in permanently shadowed craters. But what about Mars? Dry and barren today, but ancient riverbeds suggest it once flowed with water. Venus. Its clouds rain sulfuric acid. Its atmosphere traps heat, causing a runaway greenhouse effect. Solar winds strip away hydrogen and oxygen, leaving no chance for water to survive. Earth's magnetic field deflects harmful solar radiation and preserves our atmosphere. Water from the early nebula survived here and has been flowing freely ever since. Water dominates our planet in glaciers and polar ice caps, oceans, rivers, and clouds drifting high above. Sunlight strikes Earth, and vapor traps energy, helping regulate the climate. Another vital element, carbon dioxide, acts like a planetary thermostat. It keeps temperatures just right, allowing water to exist in all three forms: solid, liquid, and gas. In Earth's early years, volcanoes filled the atmosphere with carbon dioxide. Over time, chemical reactions with rocks and oceans removed some of it. Then life emerged in the ocean. Primitive organisms capable of photosynthesis. They absorbed carbon dioxide and released oxygen, transforming Earth's air and climate forever. So, it's not enough for a planet to simply have water. To be Earth-like, it must manage carbon, stabilize temperatures, and support long-term cycles that allow life to thrive. We've become explorers of this watery world. But now, we're turning our gaze outward, planets like Earth may be waiting in the darkness beyond. The Kepler telescope has already found dozens of candidates in the so-called habitable zone around distant stars, places where liquid water could exist. 2 of these planets orbit the star Kepler 62, 1,200 light-years away. They're just slightly larger than Earth and lie in the right zone for life. But what if they lack magnetic fields? Could they truly support flowing water? What if their climates aren't stable? Could they be vibrant blue worlds like ours? Or have they become scorched deserts like Venus? As we scan the skies for another Earth, we are not just seeking life. We are searching for the story of us written in the stars. What happens if the next world we find isn't just wet but alive?